Note: if satellite is orbiting close to Earth's surface, then small r, which is radius plus height from the surface, becomes approximately r. That means height is almost negligible. What is t square formula? 4 pi square upon gm into r cube. Correct, na? T square is 4 pi square upon gm into r cube.
Yes, sir.
Now, if it is orbiting close, then small r becomes capital R. What is g into capital M in terms of small g? Small g is gm upon capital R square. Correct, na? We have proved. So wherever I see gm, can I write r square g? Hello?
Yes.
So this r square and this cancel. So if you take square root, t is 2 pi, 4 square root is 2, pi square root is pi, root of r by g. So if satellite is orbiting close to Earth's surface, then time period is given by 2 pi root r by g. Copy first note. Done.
Yes, sir.
Okay. Second note: time period of satellite orbiting close to Earth's surface in terms of density rho of Earth. So again, t square is 4 pi square upon gm. Small r I am writing as capital R because it is orbiting close to the Earth's surface. What is mass in terms of density? It is density into volume. Hello?
Yes,
Mass
sir.
is density into volume, 4 by 3 pi r cube into r cube. So 4, 1 pi, 4, 1 pi, r cube we can cancel. T square equals to 3 pi upon 0. So t square, 3 is constant, pi is constant, g is constant, t square proportional 1 upon rho. So can we say that means t is proportional to 1 upon root of rho. Very important MCQ question. Everybody has followed?
Yes, sir.
Right. Again. Right. नहीं सर रुके थे सर का फोन आया था लेकिन मिसमैच हो गया ना फिर आपका डिस्कस नहीं रखो नंबर नहीं रहेगा ना और मैंने डाला इसको है ना मैं सर को क्या बोलता हूँ कि सर आप गांधीनगर तक आओ आपको गांधीनगर हाँ तो सर को मैं फोन करता हूँ वो आपसे कांटेक्ट करेंगे है ना यार क्या करना था कितना देना नहीं आपको कितना देना है बुक आ जाए बुक देखो ना उसका बुक आ देखो कैसे अभी ये बुक कल बात हुआ ना तो क्या कल बात हुआ है ना कल बात हुआ ना मतलब ज़्यादा लेट हो गया तो तुम लेगा नहीं वो नहीं बोल रहा हूँ आप बोला कल में खाई नहीं ना क्या लिखा है देखा है ना और ओरिजिनल रेट क्या है ये तो अपने के वहाँ दुकान जुना है और उसका दुकान जुने वहाँ पे बात किया तो मुझे नया लगा है उसका हम नहीं ना तो यही बुक ये होता है 2019 का पेपर ये जुलाई का ना 19 का अरे सब वो बताओ ये अपने को समझ मालूम है क्या है वो कॉपी देखो ना प्राइस कभी भी इधर नहीं देखने का जुलाई दुकान पे गए तो इधर देखने का तो इसका जरूरत है कोई क्वेश्चन और इससे रिवीजन करवाना तो उसको क्या करना भूल गया कल दे देना और वो मतलब नहीं है हाँ तभी वो देने जाओगे तो ये अपने साथ में रखना तो मतलब क्या 240 तो ठीक है नहीं तो फिर रखो अभी 2 मिनट आपको 10 मिनट लगा एक सेकंड टाइम और अभी जाके ऑफिस में हाँ ये पेमेंट आने वाला था अगर आया तो देना कितना बोला मैं बोला आज नहीं आपको कल से थर्सडे से आओ अरे थर्सडे से मैं 11 बजे अभी क्या काम है ये अपना वो नोट्स नहीं आपको नहीं लो वो अपने आप तो आप डॉक्टर का तो करना है रेडी स्टूडेंट का हां स्टूडेंट का वर्क करा ला नहीं वैसे ही हो गया पूरा बुक बनता है एंड्रॉइड से थोड़ा वैसे ही एक मिनट पहले देख लेता हूँ तो सारे रिजल्ट आ जाओ हाँ अभी अभी आ जाओ कल क्या गुरुवार है ना कल नहीं कल मैं बहुत जल्दी आऊंगा आप जब आओगे फोन करूँ तभी मैं आऊंगा क्योंकि मेरा लेक्चर स्टार्ट होगा 10:30 हाँ आप 10:30 पहले मुझे फोन करो मैं आ जाऊंगा क्योंकि मेरे को आने में 15 मिनट लगेगा अभी मैं बहुत जल्दी आके क्या करूँ नहीं तो मैं 7:10 बजे तक पहुंच जाऊंगा और इसका मैं तो इसको कर दूँ फिर कल मैं क्या करूँगा ना सर अगर बोलेंगे कि चलेगा मुझे तो मैं लेके आ जाऊंगी अगर सर बोले तो चलेगा तो मैं अरेंज करता हूँ तो अगर तो बोलो मैं आ जाएंगे और उसके बाद स्कूटर है ना तो किधर तक आते हैं कोई इधर लगा देंगे जिधर आप टर्न मारते चांदी वाली हाँ तो आपको उतना करने कम होगा नहीं वो नंबर के तो रहते हैं ज्यादा ठीक है completed this
Sir, what is the meaning of ITO?
in terms of
Oh, okay.
in terms. That's it. Can I clear this now?
Yes.
Okay. One small derivation we have to do. Right. Define gravitational field intensity and derive its expression. Define gravitational field intensity and derive its expression. Suppose this is one body whose mass is m1 and this is another body whose mass is m2. So there will be force between these two of attraction. m1 will pull m2 and m2 will pull m1. So there will be force of attraction. So if I want to check strength of first one, then I will apply force on second one. If I want strength of second, I should apply force on first. See, field means nothing but space. When you start, when your college will start, you will go to the actual lecture. Will you carry I-card or not?
Yes, sir.
Sometimes teacher is knowing you, she will allow you without I-card. If she is not knowing, she will not allow without I-card. So if teacher is knowing means my field becomes my classroom because my influence is there everywhere in my class. So wherever people know, wherever people recognize me, can I say that is my field, my space, my area? Hello?
Yes.
अभी वो स्पेस के अंदर दूसरा चार्ज अगर आया तो मैं इसको फोर्स दूंगा. See, have you seen dogs? Stray dogs, you have seen stray dogs?
Yes.
They know their territory. बाहर का कुत्ता आ गया तो भूखने चालू करते हैं ना ये लोग.
Yes, sir.
तो जब ये बाहर का कुत्ता आया इनका स्पेस में तो ये लोग इसके ऊपर अपना ताकत दिखाते हैं ना.
हाँ सर.
उसको ही बोलते हैं इंटेंसिटी. अभी ग्रेविटी के पास क्या ताकत है, फील्ड के पास क्या ताकत है, तो फोर्स किसको देगा, सामने वाले को. सो ग्रेविटेशनल फोर्स एक्टिंग पर यूनिट मास इज कॉल्ड एज ग्रेविटेशनल फील्ड इंटेंसिटी. फोर्स यूनिट इज न्यूटन, mass unit is kg, so unit is kg, Newton per kg. Again I am repeating, gravitational force acting per unit mass. Gravitational force acting per unit mass is called as gravitational intensity. intensity. It is a vector quantity. It is in the direction of force. So we can say, therefore, E is force upon mass. Force का direction और इसका direction matching. That means it is a vector quantity direction. It is in the direction of force. For gravity, it will be always inward. What will be its SI unit? ऐसा चार्ज का भी रहेगा फील्ड, उसको बोलेंगे इलेक्ट्रोस्टैटिक फील्ड इंटेंसिटी. Its SI unit is Newton per kg. Definition followed. Force acting per unit mass is called intensity. It is vector quantity in the direction of force. SI unit Newton per kg. Hello? Yeah. Write down. Simple है. Is it clear now? This again statement.
Yes, sir.
Okay. Derive expression also we had written heading. So whenever we want force, we require how many mass? One mass or two mass? Hello?
2, sir.
Two. So we can say consider a body of mass m to be situated at a distance r from center of earth, having mass capital M, comma, radius capital R. From center of earth having mass capital M, radius capital R. Therefore, gravitational force of attraction between them, comma, F will be G into mass of earth, mass of body, distance between their center, R square. So F equal to G mm upon R square. Intensity of earth, comma, E will be force acting on the neighboring mass. If I want intensity of body, then force acting on the earth. This ratio you should be able to understand. अर्थ का इंटेंसिटी चाहिए तो बॉडी को फोर्स दो, बॉडी का इंटेंसिटी चाहिए तो अर्थ पे फोर्स दो. Please copy till this. In college they have reached till this or not yet?
No, sir.
Not yet. Okay.
Done.
Okay. Everybody is done. Intensity is force upon m. Everybody is written till that. Okay. Can I clear now? Next, see. Therefore, E will become G m m upon r square divided by n. Therefore, E is Gm upon r square. This is expression for gravitational intensity. Right, 3 more lines. This is expression for gravitational intensity. Done? Hello?
Yes, sir.
Next heading, right? Define gravitational potential. Any of you know definition of electric potential from 10th standard or 9th or 8th? Any definition you are knowing for electrical potential? Akansha?
Amount of work done in bringing unit positive charge.
So work upon charge, correct. Work done to move charge. Same way here, in place of charge, we have to move mass. So we say the amount of work done, to move unit mass. Don't say positive, negative, because mass is not having charge. Amount of work done to move unit mass from infinity to a point in gravitational field is called as gravitational potential. So work done to move the mass from infinity to a point in gravitational field is called as gravitational potential. Right definition. Same thing you have done for electric potential. Potential is energy, so it is scalar quantity. By mistake, don't write unit as volt. So it's SI unit is work. Work means joule, mass is kg, joule per kg. Amount of work done to move unit mass from infinity to a point in gravitational field is called as gravitational potential. Given by W upon M, scalar quantity, SI unit is joule per kg. Yes, completed till end.
Yes, sir.
Done. Huh? Okay. What is integration of x raised to n dx?
X raised to n plus 1 upon n plus 1.
So what will be integration of x raised to minus 2 dx?
x raised to -1 upon -1.
If here I write limit of integration, what does it mean? This means wherever you see variable x,
Yes, sir.
p, then once completed, minus sign in between, wherever you see variable x, put a. Correct, na?
Yes.
Okay. See, I am interested in expression, derive expression for gravitational potential. That means you have to find work divided by mass which you have moved, you will get gravitational potential. To get work, do we require force into displacement?
Yes, sir.
This force into displacement will come when force is constant. Okay. Our gravitational force, which is gmm upon r square, is constant or variable?
Constant.
ना, अलग अलग डिस्टेंस पे अलग हो जाएगा ना. g कांस्टेंट है, m कांस्टेंट, ये बट ये r तो वेरी हो सकता है ना इधर.
Yes, sir. Yes, sir.
सो व्हेन यू कीप ऑन मूविंग दिस मास, तो उसका डिस्टेंस फ्रॉम सेंटर ऑफ अर्थ वेरी होगा ना. हेलो.
Yes.
So force is variable because it is depending upon distance. If variable, then how to find work? By integration method, है ना? So we will assume that between 2 points, which is separated by very small distance dr, force is constant. तो फिर छोटा वर्क मिल जाएगा dw, which is force into छोटा displacement. इसको इंटीग्रेट करूंगा फ्रॉम इंफिनिटी टू अ गिवन पॉइंट, तो मुझे वर्क मिलेगा क्या? नहीं, टोटल
मिलेगा.
ओके. तो दो बॉडी से स्टार्ट करूं कि एक बॉडी से? क्योंकि वर्क चाहिए, वर्क मतलब फोर्स चाहिए. फोर्स के लिए एक बॉडी चाहिए क्या दो बॉडी चाहिए?
दो बॉडी.
दो बॉडी चाहिए. एक बॉडी अपना अर्थ है ना, one body is earth, no?
Yes, sir.
And other body is that mass which we are moving, correct?
Yes, sir.
Very good. Now see the derivation. This is suppose earth, center O, radius capital R, we have a mass small m, first at distance x, then I push it by very small amount dx and bring it at distance r from center. So I want what is potential at this point P. This is suppose Q. When you are moving this mass up to P, P is at distance R, my interest is what is potential, gravitational potential at P. So first step, can I say like this? Consider a body of mass smaller at distance small x from center of earth, having mass capital M, comma, radius capital R. Therefore, gravitational force, comma, F is g mm upon x square. Let the body be moved by very small distance dx in the direction of force. Because gravity is inward, we are moving towards the earth, means along gravitational force. So work done, comma dw is force into displacement. Okay, please copy till this. Completed. Hello.
Yes, sir.
Till this over. dw is everything.
Yes, sir.
Okay. Everybody is done. Yeah. Completed.
Yes, sir.
Okay. See. So dw is g mm upon x square into dx. Now total work done to move body of mass m from infinity to a point at a distance r from center of earth, from center of earth, comma w is integration of all small work done pushing the body from infinity to r. Now it is maths actually. So g mm upon x square into dx from infinity to r. So g mm dx upon x square from infinity to r. This will become G mm x raised to minus 2 dx from infinity to r. So it is G mm x raised to minus 1 upon minus 1 from infinity to r. So I can say W is minus, I am taking outside, G mm 1 by x from infinity to r. Please copy till there. For theory, only one more lecture will be required.
Done, sir.
Now I have to simplify that integration. So wherever I see variable x, first upper value. हेलो, हाँ संजय, आया क्या नेट कनेक्शन? 1937874 150 LNT फाइनेंस निकाला. हाँ, ठीक है. So we get dw minus gmn wherever you see x First put upper value. So it will be W equals to minus G mm 1 upon R minus 1 upon infinity. Minus G mm 1 upon infinity is 0, no?
Yes.
So work upon moving mass m is minus gmm into 1 by r. That is gravitational potential V is minus G capital M upon R. Right.
That
No. V is work done upon moving mass. What is capacity to do work is called as? Capacity to do work is called as what? Say, what is capacity of work?
Energy.
Energy. So if you are moving a body very slow so that its velocity is maintained constant, then this energy which we are getting as potential due to work, that work is called potential energy, because we are not changing the kinetic. We are moving it so slowly that velocity at every point almost remains constant. So we can say this is potential energy upon mass. So minus Gm by R is potential energy upon mass. So potential energy is minus Gmm upon R. So whenever it is potential energy of the body at a distance R from center of Earth, I will write minus Gmm upon R. Please write this note, very important for next derivation. हेलो आकाश, अपना 85219 में बजाज फिन सर्विस 3 आएगा क्या? चलेगा सर, हाँ ले लो, चलेगा 3 बजाज। नहीं सर, फिन सर एक बार, बड़ा वाला। चलेगा हाँ। ओके। यस कंप्लीटेड।
Yes, sir.
ओके, एक छोटा सा और चीज एक्सप्लेन करता हूँ। फ्रिक्वेंटली रिक्वायर्ड सेकेंड पॉइंट, दिस इज सेंटर ऑफ अर्थ, whose radius is r. I throw a body from here up to certain height h. See, in your lower standard you take this as reference and say potential is mgh, but actually center of earth is our reference. So can I say at this height potential energy will be greater than potential energy on the surface or not? Tell. Hello.
Yes, sir.
If I throw body from surface to the height h, then can I say potential energy will be increased?
Yes, sir.
Yeah. Now suppose h is nr. So what will be increase in potential energy? Can I say it is nothing but potential energy at height, which is equals to n times r minus potential energy on the surface? Potential energy at height means minus gmm upon r plus h, and on the surface it is minus gmm upon capital R. So minus g mm r plus h, I told let it be n times r plus gmm upon capital R. So minus gmm r into 1 plus n plus gmm upon r. What will be LCM? Will it be r into 1 plus n? Hello? LCM, will it be r into 1 plus n?
Yes, sir.
Okay. So minus gmn plus gmn into 1 plus n. Gmm common. Inside we can get minus 1 plus that 1 plus n upon r into 1 plus n, minus 1 plus 1 cancel. Please copy till this. Very, very important. Whenever it is increase in potential, one formula I will obtain now, that you have to tell me. Height from the surface we have taken n times r. It can be 2r, it can be half r, we don't know. N is just one multiplier. Anmol, completed?
Yes.
Can you tell me what is G into capital M in terms of small g? No, Amay, are you able to remember? Capital G, capital M? Very good. R square G.
Sir.
R square G, correct. Into M, into N, upon R, into 1 plus N. 1 R we can cancel. So finally we got N upon N plus 1 mgr. So henceforth, whenever body is thrown from the surface such that height is nr, then increase in potential, you will tell me directly N upon N plus 1 mgr. Most of the time they ask one numerical based on this. Copy now till end. Next lecture we'll be able to complete entire theory of this chapter. So this week you will have test on theory of gravitation.
Done, sir.
So that's all for today. Let's meet on now. Friday as usual lecture. I'll be completing entire theory on that day.